Hi guys! Finally, the price of the new Centauri carbon from Elegoo has been revealed, and we now have our review ready to share with all of you. You want to know more? Then stay tuned! Hi guys, welcome back. My name is Rui, and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description. Recently, Elegoo launched two new 3D printers to the market, the Core XY Centauri and the Centauri Carbon. The major difference between these two models is the enclosure. So, in our previous video, we shown you our Centauri Carbon and we talked about the specifications that the manufacturer announced, and we unboxed and assembled our machine. We have been testing this new printer for over a month now, and we are ready to share a more detailed review. But first, let's start by giving a brief summary of its features, and then we will show you some of the prints we have made and share with you our true opinion about this new 3D printer. As you could see in our previous video, the assembly was extremely simple and quick. The printer is completely enclosed with a tempered glass door at the front and a removable cover made from the same material at the top. The internal structure and outside covers are all metal, making it very sturdy. At the front, we have the display, which is a 4.3-inch capacitive touchscreen, and a USB input. On the right side, we have the filament spool holder and the filament input with the filament runout sensor. At the back is the air input for the auxiliary fan, the filtered air output, and the filament purge exit. Regarding the axis, the machine is a Core XY with the X and Y axis driven by belts on metal rods. Each belt has a spring mechanism to help adjust the belt tension. For the X and Y axis, we can find them at the back of the printer. The Z axis is driven by 3 lead screws and 1 belt. To adjust the belt, we need to open the bottom panel, and we will show you that in a few minutes. The X and Y axis stepper motors are these big and strong models. The print bed is equipped with sensors that are used for leveling and Z offset calibration. For print surface, it has this flex magnetic metal plate with 2 different textures. On one side we have a more rough texture and where we can use with all the materials. And on the other side, the texture is smooth and designed for PLA and with a superior adhesion capability. The print volume of this printer is 256 mm on all 3 axes. The setup on this one is direct drive with the extruder inside the print head. The top cover can be easily removed since it's secured by a couple of magnets. Inside we can see the extruder at the top and the hot end and cooling fan under it. At the side, we can see a lever. This is used to move a blade inside to cut the filament. The nozzle installed on this one is a 0.4 mm and can handle temperatures up to 320 degrees C. The hot end can be easily replaced by removing these 2 screws and a couple of connectors. Elegoo also has more nozzles with different sizes such as 0.2, 0.6 and 0.8 mm. On the cover is a big blower fan to cool down the layers through these 2 fan ducts. The cable and PTFE tube go inside a cable chain, and the cable is connected to the print head by a connector secured by a couple of screws. At the back is the filament purge chute and a rubber piece to clean the nozzle tip. There's actually a second one that came with the extra parts as spare. From here, we can also see the air output that comes from the auxiliary fan. This one is extremely helpful when printing at very high speeds. Next to it is the fan and filter for air removal from the inside to the outside. The filter will help to capture small particles. And at the front corner is the camera and the internal light. As we normally do on our videos, let's check the electronics. All the main electronics are located under the printer. We need to turn the printer on its side and unscrew the bottom screws to remove the panel. The power supply is this one. It's not a powerful power supply because it's not used for heating the heat bed. The heat bed is AC powered and controlled by this small board. The main board is this one. It's equipped with a dual-core processor and 8 GB of internal memory to store user data. It's also equipped with silent drivers, Wi-Fi, and USB. Also under the printer, we can see the belt that moves the Z-axis and the mechanism to stretch the belt. When loosening the two screws, the spring pulls the idler back and to the correct belt tension. To check the X and Y axis belt tensioner system in more detail, we open the back panel. To adjust each one, we need to loosen these screws and let the spring move the idler to the correct belt tension. Then we can retighten the screws and check the belt. When turning on the printer for the first time, we have to follow the initial setup. First, we have to choose the language. Then we have a message warning us to remove the 3 screws to unlock the table, and then to check that there's nothing inside the printer. Then the machine will start the self-check process and ask to place the print surface on the bed with the side A facing up. The process will take a few minutes. During the self-check, the following parameters are tested: nozzle heating, heat bed heating, heat cooling fan, mainboard cooling fan, input shaping, and automatic leveling. After the self-check is complete, we have access to the main menu. In here we have some buttons and information. There's a button to turn the internal light on and off, the information about the Wi-Fi connection on or off, the nozzle temperature, the heat bed temperature, and a button to turn on and off the cooling fans. There's also the information on which IP the printer is using and the chamber temperature. On the second left tab, we have the files to print. There's the internal memory folder, the USB drive, and the print history, where we can access all the prints that we have done. Next is the menu where we can control all the axes. In here, we can move the axis, home the axis, and disable the stepper motors. We can also check and change the nozzle and heat bed temperatures. As for the chamber temperature, we cannot control it, but we can read its temperature. There is also a button to change the print speed. In fan, we can turn on and off and control the auxiliary fan, the model fan, and turn on and off the case fan. We measure the sun level of these 3 fans, and this is the result. As you noticed, the loudest fan is the auxiliary fan. This one is actually very loud. This fan is used to cool the layers when printing at high speed. With the printer fully closed, the noise levels go down. But for some filaments such as PLA, we really need to have the door or top panel open, otherwise we will have printing issues. Okay, back to the display. There's also a menu for the extruder where we can load and unload filament. On the settings menu, we can change several things such as the display brightness, the screen on time, the language, the Z offset adjustment, although this one is done automatically, but you can still do a manual fine-tuning if you want to. Export logs, time zone, select the build plate side A or B, and this can also be selected when exporting the model through the slicer. Check and update the firmware, restore the factory settings, enable or disable the power loss recovery and the filament detection. On the network menu, we can turn the Wi-Fi on and off and select the Wi-Fi network. On the info menu, we can check the printer's information, such as the device model, print volume, serial number, total print time, manufacturer name and contact, and at the right side is the internal memory usage. On the camera menu, we can turn on and off the time-lapse capture. And here we can access the time-lapse videos and export the ones we want. And finally, on the calibration menu, we can run the automatic leveling calibration, run the vibration calibration, the PID calibration, and the auto self-check. Okay, time to test the printer. To load filament, we take the spool, place it on the spool holder, and push filament through the PTFE tube all the way. On the print head, the tube does a tight curve, so we might need to push a bit harder to pass the curve. When that is done, we enter the extruder menu, select the filament temperature and click on load. The printer will first heat up the nozzle and then will pull the filament. If we pushed the filament all the way in, it should be able to push it by itself. If not, we need to give a little push. To unload the filament is easier. We just need to click on unload and then the printer will trigger the lever and cut the filament in the process. At that time, we can pull out the filament. Elegoo Slicer is based on Orca, and if you know how to work with Orca, you will not notice any difference. Simply start a project, place the model, select the printing parameters, and finally click on Slice Plate. To start the print, we need to either send through Wi-Fi the file to print or load a flash drive with the files. To access the printer and after setting up the Wi-Fi network on the menu, we can use an internet browser or the slicer. It's also possible to enable the time-lapse feature when starting the prints. We made several prints with different types of filaments. The first ones were done in PLA and we printed the already sliced ones that came with the printer. One of them is this 15-minute benchy. We first printed with the white PLA sample that came with the printer and then we printed again with our own filament. During printing, we can see the model on the display. The benchy was printed in 15 minutes but not counting with the initial time for heating up the nozzle and heat bed and the leveling. Both of them look very good. This is the white one made from Elegoo's filament. The walls are very smooth and we can't see any issues. And this is the one with our filament. Since the model was already sliced, we couldn't make any adjustments. But in the end, we didn't need to because it turned out very good, especially considering that it was printed with high speed. Then is this small Eiffel Tower that also turned out very nice. All the small details are there, and the overhang areas are fairly decent. There's also this vase, which was not made in vase mode. This is actually a nice model, and it was printed perfectly. Also already sliced is this bucket with the shape of the printer. It turned out okay, and if you look closely, you will see a different color at the top. This is because we decided to test the filament runout sensor, and so we cut the filament at the entry of the sensor. The first thing that came to mind was that the filament runout sensor was installed outside the printer and far from the print head. So when the filament ran out, it would still have plenty of filament inside the PTFE tube, and we wanted to know how the printer would manage that. It turns out that after the sensor is triggered, the printer will keep running for several minutes before stopping. When the filament end is close to the print head, the printer stops, purges the remaining filament and displays the message to reload more filament. And as you can see, the printer resumed the print perfectly. This bucket can be used to collect the filament purges at the back. We can install it by loosening the 2 screws near the purge exit and place the bucket there. In the internal memory, there's also this small figure. It turned out okay, except for a little ripple on it. We also printed models that were not on the printer's internal memory and that we sliced ourselves. We made a couple of prints in place gear models in ASA and PLA. Both models turned out okay, and since they were printed in place, we tested the gear movement and it works fairly good. Also printed with ASA is this drill dust collector. It turned out perfectly fine. The edges are a bit rough, but it's from the brim that we simply pulled out. We also tested with TPU. We used the generic TPU profile that is on the slicer with no modifications. And it turned out quite nice. There's only some stringing on the head of the model, but this is just an indication that we need to fine-tune the slicer profile. With ABS, we printed this 6 solid-state drive rack. It was printed without supports and it turned out okay, except for some ripple on one of the sides. We have to mention that all our test prints were done at the higher acceleration and speeds. We did a few more and bigger prints, such as this frog done with multicolor filament. Again, a bit of ripple here and there, but overall very nice. There's also this pencil holder. There are some artifacts, but these are from the model itself and not from the printer, as you can see from the slicer view. We also printed this print-in-place snakes. We used multicolor PLA filament and they turned out great. As for printing with PETG, we also had no major issues. We printed this benchy with the generic profile without modifications. The result is very good, except for this defect at the front of the boat, which suggests that we need to do some fine-tuning to the profile to get it better. As for time-lapse videos, although they look nice, they could be a bit better with a stronger internal light. We can see that after the table goes down a bit, the camera's brightness kicks in, resulting in a variation in the video. As we mentioned before, we can access the printer using an internet browser or the slicer. And since it doesn't work on a cloud, we don't need to create and log in to any type of account to access this printer. The downside of this is that we can only access and monitor the printer if we are on the same network. The printer's firmware handles motor motion control, path calculations, and host device communication on a single chip, which is a bit different from Clipper. However, it still includes key features like resonance compensation and pressure advance, but is not compatible with open source Clipper commands or plugins like Fluid, for example. As for the pros and cons, and on the positive side, we have the assembly. The printer is almost fully assembled. We only need to remove the 3 bed lock screws, attach the display and the spool holder to have it assembled. Then is the first calibrations and checks, which are done automatically, and it's ready to run. It has a Core XY construction and the internal frame is all metal and very sturdy, which makes it capable of sustaining high speeds and accelerations. It's fully enclosed, which allows the use of filaments that require a warm environment. It's equipped with sensors that allow some calibrations to be done automatically, such as leveling and Z offset. vibration compensation, and filament runout. It has an internal light and camera for remote monitoring and time-lapse recording. On the other hand, the internal light is very weak. If you are printing with the top cover and front door closed, it gets even darker and difficult to see. This was reported to Elegoo and they promised to improve this. The magnetic steel print surface has very good adhesion, especially for PLA. We made lots and lots of prints and we didn't need to use any kind of adhesion promoter. It's a direct drive setup with a hardened steel dual gear extruder. The hot end can reach 320 degrees C and it can be quickly and easily replaced. The blade between the extruder and the hot end can cut the filament automatically, which makes the filament removal much easier and stress-free. It's equipped with a nozzle tip cleaning rubber and filament purge chute. The filament placement and loading are done at the side, which is easier. It has a very nice display and very easy to work with. The interface is also very user-friendly. The machine is equipped with Wi-Fi, so we can use the slicer or an internet browser to access the printer. There's also a USB connector if we want to use a flash drive to load files to print. A USB flash drive is a better solution when compared with a memory card because flash drives are everywhere and they don't need any adapter to connect to any computer. Elegoo slicer is based on Orca, which is very nice and easy to work with. The profiles included also work well for generic filaments. Firmware updates can be checked automatically on the printer's display, and the download and installation is done automatically. This machine can print really fast and maintain a very decent print quality. And finally, the price. We were surprised with the price of this printer because, in our opinion, it's a very good price for the amount of features and quality that this printer has to offer. And if you check the pre-order price, which at this moment is only $299.99 US, it's even more surprising. And on the negative side, we also have the auxiliary fan. While most of the fans are pretty silent, the auxiliary fan on the other hand is extremely loud. For prints with filaments that require operating with the front door open, such as PLA, it gets quite annoying. And even if you don't use that fan while printing, it always turns on for a few seconds before each print starts. On this model, since the filament is loaded on the side of the printer, we can see that Elegoo thought about the user access, but forgot about the on and off switch by installing it at the back. It would be much easier if they installed an on and off switch at the front. For now, there is no multicolor solution available. Not sure if Elegoo will include it in the future, and if they do, not really sure how they will connect it to this machine, so let's see. A filament flow sensor would be a nice thing to have, so we could get an automatic flow calibration as well. However, we agreed that at this price range, the printer is already pretty good. When we received the printer, we noticed that the video transmission was not very stable. It would stall and fail a lot, but since the latest slicer upgrade, it got a lot better. We decided to include this here mainly to report this, but we can confirm that so far, it seems that the issue was indeed fixed. The printer is not equipped with a sound alarm to warn us when something is wrong. There's only a warning message on the display. Same thing when loading the filament. You need to wait for it to heat up the nozzle and all that, and you need to pay attention to the display for when it starts pushing the filament in. So, in conclusion, this printer has very good features and good printing results for such a low price. The fast printing speeds and hardware quality also adds up to its success. For the guys that don't need automatic multicolor printing or AI monitoring, this might be a good option to consider. So, what do you guys think about this new printer from Elegoo? Feel free to leave your comments below. And that's it, you guys. Thanks for watching. We will see you guys next time. Bye!